Okay, so 3.5 is all about the slopes of lines. And we just talked about with our bell work how the slope of the line is going to describe the steepness. Um, when you have the slope, in addition to the slope formula that we talked about, if you have your line on a graph, a popular way to find it is the rise over the run. The rise is going to be the y values, so that's like your vertical distance. The run is going to be your horizontal distance. Okay, so your rise is your vertical distance, and then your run is your horizontal distance. Your slope is what is called a ratio of the rise to the run. A ratio is just when you are comparing two different values, and a lot of times we use a fraction to compare them. This is the slope formula that we mentioned in our bell work. So whenever you have 2 points, you can always do y2 minus y1 over x2 minus x1. It's really the change in y over the change in x. And then for our first example, you are given 2 points. You are going to graph the lines and calculate the slope. So if we're going to graph the lines, the first thing we have to do is actually put in our grid. Okay, so we're going to put in our x-axis and our y-axis. So when you're putting those in, keep in mind you have to plot 1, 1 and 5, 7. So think about where you want to put those. So you're going to have to go to 5, 7. You guys can calculate it. And really, since they are both positive, could even put them there. Okay, so you are graphing, it says the lines, but it really is just the line. Okay, and then let's go ahead and plot our points. So our points are 1, 1. And I'm just going to label this as my 1, 2, 3, 4. Okay, at least label a few just so we know what scale that you're using. So here's your 1, 1. And then 5, 3, 4, 5, 6, 7. Okay, and then you can just use a straight edge to connect. And I'll actually pass out some straight edges if you guys need those. Okay, and it is a line, so I'm going to put my arrows on both ends. And then I'm just going to show you a couple of different ways that you can find your slope. So 1, 1, 5, 7. And then, like I said earlier, you can choose which one is your x1, y1 and your x2, y2. It's just the ones have to go together, the twos have to go together. So to find your slope, you're going to do 7 minus 1 over 5 minus 1, which would be 6 over 4, and then you have to reduce. So what goes into both 6 and 4? 2. So if I divide the top by 2, I get 3. If I divide 4 by 2, I get 2. So your slope is going to be 3 over 2. Now, when you have this in a graph, you can also use your rise over your run. So if you count from your point here, you're at 1, 2, 3, 4, 5, 6. Okay, so your rise is 6. Your run is 1, 2, 3, 4. Okay, so this is 4 units. This is 6 units. So again, you would get 6 over 4. That reduces to 3 over 2. And you could do it that way as well. Okay, especially if you're graphing that, that is a quick way to do so. All right, so now we're going to do just a quick summary of the slopes of a line. So if there's a positive slope, we're just going to draw like a rough sketch here. So if you have a positive slope, if you're looking at the line from left to right, what direction is that line going? It's going to be going up, right, from left to right. And it really can be anywhere. You just have to show that it's going to be going up from left to right. Okay, so line goes up. From left to right. Okay, and then for the negative slope, if the positive one goes up from left to right, the negative slope is going to go where? Down from left to right. We'll use a different color for that. So again, doesn't matter where you put that or how steep it is, as long as it's going down from left to right. So I'm just going to put down from left to right. So L to R is left to right. If it is a zero slope, do you guys think you remember what that looks like? This is a special type of line. Nope. Well, it is straight. It's not straight up, it's horizontal. Yep, so it's a horizontal line. Do you guys have any special tricks for remembering that? That it's zero. Okay, so this would be a horizontal line. This is how I remember. So the horizontal line, you were to draw the horizontal line, it's like the Z in 0. Because for the undefined, if it's undefined, that's when it's a straight line that's what? Vertical. I don't think you guys can see this one very well. That is electric. Okay, so this one is a vertical line. And the slope is undefined, so the way that I remember that is you can start the U with the vertical line. Okay, so the U for undefined would be with the vertical, the Z with the horizontal. So those are just some tricks my teacher taught me when I was just a young girl like yourselves. Well, or a boy. So these are just different types of slopes that you're going to encounter. If you have a horizontal line, do you guys know what the equation looks like? What axis does the horizontal line go through? It goes through the y. See how it intersects with the y? So whenever you have a horizontal line, your equation is going to be y equals some number. Okay, so I'm just going to say y equals c because it's going to be a constant term. When you have a vertical line, the equation is going to be x equals some number. So again, I'll just call that c. Okay, and then we're going to talk about our other different forms of writing our lines. So one way you can think about slope is thinking of it as a rate of change. Okay, and actually a rate of change is going to be used in different subjects. You guys can use it in science. A lot of times when they write the slope, they'll write it as like a little triangle. We just talked about rate of change in pre-calculus. And then as you go into some economics, if you do AP macro, AP micro, you're also going to be talking about rates of change. So one specific application is determining miles per hour. Okay, so the rate is your miles per hour. You would think of y as the miles, and you would think of x as the hours, because it would be a fraction like this, miles per hour. Okay, so the change in y is on top, the x is on the bottom. So we have our buddy Justin who's driving home to his college dorm. At 4 o'clock, he is 260 miles from home. At 7 o'clock, he is 455 miles from home. We're going to graph the line that represents Justin's distance from home at a given time. Okay, so I'm just going to highlight some of the important information they gave us. 4 o'clock, he's 260 miles from home. 7 o'clock, he's 450 miles from home. So we're graphing the line that represents his distance from home at any given time, and then we have to calculate the slope as well. So when you're given this data, it's going to be useful if you can organize that into a point. So 4 o'clock, he's 260 miles from home. I would think of that as 4 as my x, and then my 260 miles. So remember we said our y was going to be our miles, our x was, you can think of x as hours, that's going to be your time. So for 7 o'clock, he is 455 miles from home. So when I go to graph these, I'm going to have to think about my scale. Okay, so here's my y, here's my x. These are only going to be positive. So this is going to be your time. Okay, so 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8, 9, 10. Okay, and then the y is going to represent your miles. Which is your distance from home. Okay, so the distance from home is measured in miles. All right, and then I know I'm going to have to go up to 455, so I want to make sure that my graph reaches that far. If I went by 100, I would definitely have room. I probably even have room to go by 50. So this would be 100, 150, 200, 250, 300, 400, 500. So now I can plot my 2 points. So I have 4 260, so I'm going to estimate. I know that this right here is 250, so 260 is going to be a little bit above that. And then 7, 455. So again, this is 450, so that's going to be really close to that line. And then I'm going to use my straight edge to go through those points. And then you do want to just span your entire graph. Okay, now this is not going to keep going because we are not going to have a negative amount of distance from home. And so now we're going to calculate the slope. So we can do our slope formula, y2 minus y1 over x2 minus x1. Like I said, I like to label these my x1, my y1, my x2, my y2. So I'd have 455 minus 260 divided by 7 minus 4. Okay, so 7 minus 4 we know is going to be 3. Can you guys see how close 455 is to 460? 455 is close to 460, right? So like the difference between 460 and 260 is 200. So because that's only 5 more away, you would just take 5 away, which would be 195. That's just a way you can do it without your calculator. Okay, and then how many times does 3 go into 19?
6 times.
6 times, because 6 times 3 is 18. So you'd have 1 left over. So if you bring down the 5, 1 and 5, how many times does 3 go into 15? 5 times. So that's how you could get 65. So this would be 65 miles per hour. Okay, and again, that's because your y is in miles. This would be in hours. All right, and then on the back we have a couple of new theorems. So one is about parallel lines, the other one is about perpendicular lines. Okay, so your parallel lines theorem says that in the coordinate plane, if you have two non-vertical lines are parallel if and only if they have the same slope. Okay, and then any two vertical lines are parallel. So to recap, what this is saying is parallel lines are going to have what? What are parallel lines going to have? The same slope. Okay, so if the lines are parallel, they have the same slope. Okay, in a nutshell, that's what this is saying. For the perpendicular lines theorem, it says in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, so the product of their slopes is -1. Now, when it says product, what does product mean? You say it again? So the sum will be like when you add, the product will be when you multiply them. So if you were to multiply the two slopes together, you would get -1. Okay, if they're perpendicular. Okay, so for perpendicular lines, There are really two ways that you can think of this. So when you multiply the slopes, that equals -1. Or sometimes you might hear them referred to as opposite reciprocals. So when you look at the word, the opposite represents the sign. So if one is positive, the other one is negative. To form a reciprocal, what do you do with the value? Yeah, you flip it. If it's a fraction, you can flip it, or you put it, no? Yeah, put it over 1. Okay, or you flip it. So you can do either one of those. And then I just want to talk to you about this part where it says 2 non-vertical lines. When it says non-vertical, can you picture what a vertical line looks like? Yeah, so it's straight up and down. So they're just saying if they're non-vertical, they'll have the same slope. And that's because if they are vertical, if they're both vertical, aren't they already going to be parallel? Yeah, because their slope is what? Yeah, and what is it specifically for these? Undefined, right? They're both undefined. And then with this one, it says vertical and horizontal lines are perpendicular. So if you have a vertical line and a horizontal line, those are automatically going to be perpendicular. Okay, so this is a big thing, and we're going to be practicing that a lot. So you're going to have to graph each pair of lines, and then you are going to use their slopes to determine whether they're parallel, perpendicular, or neither. So you're going to graph, you're going to find the slopes, and then you're going to have to say if they're parallel, perpendicular, or neither. Okay, so you are going to have to make your grid. So for your homework, I'll have you do that on graph paper, and if you don't have any, I have some for you. Okay, so then you're going to plot your points. So you have 0, 2 for U. So when you plot your point 0, 2, you need to label it. Okay, so this is U. So make sure you label it with your U. Your V is -1, -1. So you're going to label that with V. Now you can't just assume based on how they look whether they are parallel, perpendicular, or neither. So make sure that you do prove it using what we just learned. And then for X, I'm at 1, 2, 3, 1. So again, label your point. And then you have 1, 2, 3, 1, 2, 3. Now, one thing you can tell right away is these are not going to be what? Parallel. They're not going to be parallel. Why? They intersect each other. Okay, so what we're going to do is we're going to find the slope for both of them. So we'll find the slope for UV. And so for U and V, you can think of this as your x1, y1, x2, y2. You have -1 minus 2 on top. On the bottom, you have -1 minus 0. -1 minus 2 is -3. -1 minus 0 is -1. What happens when you divide a negative by a negative? You get positive, so it's +3. Okay, so now we're going to find the slope of xy. So this is my x1, y1, my x2, y2. So I have 3 minus 1, 3 minus 1, and then negative 3 minus 3. So 3 minus 1 is 2, negative 3 minus 3, negative 6. Remember, you always have to reduce. So what goes into both? 2. So if you divide by 2 on the top and the bottom, you'll get negative 1/3. So if they're parallel, they're the same. Are these the same? Nope. If they're perpendicular, when you multiply them, what do you get? Negative 1. So let's find the product. So the product would be 3 times negative 1/3, which is really like, right? If you have 3 over 1, multiply straight across. You have negative 3 over 3, which is negative 1. So if the product is negative 1, what does that mean? They are perpendicular. Remember, I also said that they're opposite reciprocals. So look at this one. See how it's negative and this one's positive? The reciprocal, 1 over 3 would flip to what? 3 over 1. And isn't 3 over 1 just 3? Yep. So they are opposite reciprocals, which is the same thing. Okay, so those are perpendicular. We're going to do the same thing with the next one. Okay, and I'm going to give you just a couple minutes for you to graph it. And then once you graph it, go ahead, find your slope. When you graph, again, make sure that you labeled your points. So make sure you labeled your G and you labeled your H. Let's see. Okay, so will you guys just double check and make sure that you did label your points correctly? And then you're going to find the slope of both of those. So the slope of GH. And you're going to find the slope of IJ. And if you want, you can use your rise over run. So you could do, oops, sorry. Okay, so you could count your 1, 2, 3, 4. That's your rise. 1, 2, 3, 4. That's your run. So you could do 4 over 4. If you're using your equation, I just want you to be careful of one thing. So notice how here I would have 2 and then it's a minus a negative 2. When you have 2 minus negative 2, what happens? It becomes plus, right? 1 minus negative 3. Okay, so that becomes 2 plus 2, 1 plus 3. which is 4 over 4. What's 4 divided by 4? 1. Okay, and then this is your second set of points. So for this one, you'd have negative 4 minus 4 over 2 minus negative 2. So this would be negative 8 over, minus a negative would be plus a positive, so that would be 4, which would be negative 2. Okay, so are these the same? Same? No, so they're not parallel. Does their product equal negative 1? What does it equal? Yeah, negative 2. So this one is definitely no. Their product is negative 2. Okay, so then our answer for this one would be what? Neither. Neither, neither. Tomato, tomato. Okay, so I'm going to give you time to do the last one. Let's see how you do. And then if you're already finished, just check in with your algo partner. See if you guys got the same thing. Make sure with your lines that you put your arrows on. Okay, and then when you're done, you can check it with mine. So this is another one where when you have your x1, y1, you had 1 minus a negative, which is going to be plus. 1 minus negative 1, which is going to be plus. So when you calculated both of your slopes, and then for EF, 3 minus 1, 0 minus negative 1, okay, which would be 2 over 1. So when they're the same slope, it's going to be parallel. Okay, and again, just remember that you always are going to reduce. Okay, you always have to reduce your slopes.